bisa kita coba carikan solusinya bersama. Yang berikutnya terkait inovasi dan hilirisasi produk. Ini yang tadi saya sampaikan. Jadi saat ini kita sebagian besar teman-teman yang ada di industri sabut kelapa di Indonesia masih mengolah barang setengah jadi, yaitu kokopit dan fiber yang secara value masih belum maksimal. Yang berikutnya tadi daya saing kita sangat rendah, terus terang kita masih sangat jauh ketinggal dibandingkan Sri Lanka, India, dan Vietnam. Ini akibat yang paling fatal dari sisi logistik atau dari sisi geografis, karena Indonesia merupakan negara kepulauan, sehingga logistik cost kita sangat tinggi. Nah, ini saya sampaikan data yang cukup menarik. Mudah-mudahan nanti beberapa delegasi yang dari Cina terkait sabut kelapa, karena saat ini hampir 90% lebih produsen cocoa fiber atau produsen sabut kelapa itu ekspornya ke Cina. Jadi baik itu dari Indonesia, dari Sri Lanka, India, Vietnam itu ke Cina untuk cocoa fiber. Tapi saat ini di Cina sedang mengalami penurunan harga. Jadi yang biasanya per metric ton itu sekitar 300 US dollar, saat ini di angka 150 sampai 160 dolar. Akibatnya biaya pengiriman, biaya transportasi cukup tinggi dan tidak menutupi secara cost produksi. Sehingga beberapa industri yang ada di Indonesia, cocoa fibernya harus dibakar karena ini belum dioptimalkan. Nah, ini tentunya menjadi salah satu opsi atau salah satu potensi yang bisa dikembangkan bagaimana produk dari cocoa fiber ini bisa dielaborasi, bisa dicarikan solusinya, produk-produk apa yang sebetulnya potensial untuk dikembangkan. Nah, kalau kita berbicara kebutuhan riset dan inovasi dari sabut kelapa, ya, kebetulan saat ini PT Koir Indonesia sedang bekerja sama juga dengan BRIN terkait pengembangan genteng komposit. Nah, tapi secara keseluruhan untuk industri sabut kelapa ini kita satu perlu pemanfaatan seluruh bagian dari sabut kelapa, karena kalau kita lihat di lapangan itu masih ada beberapa waste dari produksi cocoa fiber dan kokopit yang belum dioptimalkan. Yang berikutnya juga tadi yang saya sampaikan perlu ada pengembangan produk alternatif dari sabut kelapa atau dari cocoa fibernya itu sendiri. Karena kalau tidak, secara industri kemungkinan teman-teman banyak yang tidak bisa bertahan karena saat ini sebagian besar teman-teman atau pelaku industri ini hanya memanfaatkan kokopit sebagai media tanam. Itu yang menolong teman-teman dari industri sabut kelapa yang ada. Nah, tentu otomasi atau mekanisasi produksi perlu mendapatkan perhatian sehingga tadi pengembangan mesin-mesin teknologi terapan yang baru yang lebih efektif, lebih efisien ini sangat diharapkan untuk bisa meningkatkan daya saing industri sabut kelapa yang ada di Indonesia. Ini beberapa aplikasi yang sebetulnya bisa kita dorong tentunya dengan kolaborasi terkait pengembangan produk-produk turunan, karena yang kita tahu mungkin di Cina untuk sebagian besar produk turunan dari sabut kelapa atau dari cocoa fiber itu digunakan untuk industri matras. Nah, ini yang sebetulnya dari sisi market, potensi market di dalam negeri juga cukup besar. Yang berikutnya untuk pengembangan industri otomotif, nah ini juga potensinya sangat cukup besar, tinggal bagaimana adanya kolaborasi antara industri dengan dunia riset. Nah, yang tidak kalah menarik juga terkait pengembangan atau pemanfaatan sabut kelapa untuk material-material bangunan, gitu. Jadi ini merupakan tantangan dan kebutuhan sekaligus kebutuhan dari industri untuk bisa melihat dan mengoptimalkan potensi sabut kelapa yang ada di Indonesia. Mungkin itu Bapak Ibu, terima kasih atas waktunya. Sekali lagi mohon maaf atas kekurangannya. Terima kasih. Wassalamualaikum warahmatullahi wabarakatuh.
You, Pak Cepi. Okay, please give applause for Pak Cepi from PT Koir. So maybe at a summary, that has been established as illegal since 2024. Coconut fiber, such as cocoa fiber, cocoa peat, coir log, and other some of the from agriculture application. A good, that's only maybe 10 until 50 source from Indonesia. And by this FGD, they hope that maybe can make any that's all. So thank you. We will have a discussion after present. We will Mr. Ha Changbin. Hello, Mr. Ha. PT Carbon Prima Jaya.
Yes.
Activate session, please, Mr. 30-year experience lead of the PT Carbon Prima Jaya. Please, Mr. Ha, the time is yours.
Hey, hello.
Yes, Mr. Ha. Hello.
Actually, I don't understand why you invite me.
Okay, so Mr. Ha, as we
Yes.
maybe by change product in the PT Carbon Prima Jaya, and also you might have a challenge and also hope in the future for the increasing the maybe about your product that coming from our discussion that your product maybe this
Sorry, your voice is very, very garbled. So, okay. I want to tell you about the common sense of the active carbon for production in here, because usually active carbon from the coconut shell in whole world, as you see, the quality of coconut shell is the best quality is in product in Indonesia. So I built my factory in 30 years ago. And the use of the active carbon usually using to water treatment process and wastewater treatment process, and air pollution also. As you see, in your home, you also have your what I told you, that you also have a water filter. In whole of in the world use the water filter using active carbon, but the active carbon is the essential part for our life, because all contaminations and usually for cause of the cancer or something, the other disease from the water, air pollution, something like that. The most important thing is activated carbon to extinguish the contamination also. But actually, we also met the last week. I heard that you also want to the high quality for the energy, the active carbon for high performance energy storage or capacitor, something like that. The class of the active carbon for use the energy part, the class is different. My factory is only for common things to produce, for yes, water treatment or wastewater treatment also. So you see, in Indonesia, if you want to, what kind of active carbon you want?
Yes.
Actually, you want the high quality, as I see in whole Indonesia. No factory can produce.
Okay. Thank you.
So in Indonesia, using the coconut shell is usually produced for common quality of active carbon. But at previous part told Sri Lanka, India, Vietnam, also that they have their actually good quality produced in Sri Lanka for using the for coconut fiber. But in whole of the world, the majority produce of active carbon is China.
In China, okay.
Yes, using the coal, batubara. Actually, whole of the 80% of the active carbon, all of the world is produced in China. But the high quality and for human beings, the good resources, bahan baku, is coconut fiber.
Okay.
And then the price, actually, yes, I export to America, Korea, and Saudi Arabia, Japan, usually 30,000 US dollars per ton. But the raw material of coal base usually deep below the 1,000 US dollars. So in Indonesia, actually, what the most important thing is the coconut fiber, and also same thing, coconut beans, something like that. The coconut shells come from Indonesia, actually good quality. But, in business of the coconut.
With connection with the
Yes, the connection is something cut
much
off.
for yourself. Do you still can hear us, Mr. Ha?
Yeah.
Okay. So
Okay.
is anything you want to add more about your activity in the PT Indocarbon is enough?
What? Sorry? Your voice is covered.
Do you still have anything to share with us about the Okay, so we will move to third speaker. So thank you so much, Mr. Ha. So we will have discussion at the end of this session. So everyone, so as for your information, that the PT Carbon Prima Jaya, the main product is activated carbon that usually only focus on the two application, water treatment and also air treatment. As we can know that if we check in the air conditioner, fan, refrigerator, and other, and also when we drink the mineral water, they usually use active carbon with the high properties that as mentioned by Mr. Ha, one of the good resources is coconut shell coming from Indonesia. Okay, thank you. We will move to Mr. Fano Alfian. He is a director of the PT Indo Carbon Prima Jaya. So hello, Mr. Vano. Yeah, and also about the business area, the PT Cipta Inovasi Berkelanjutan, or we call alias Indonesia, it focus on the energy and environmental service company to transfer eco-efficient solution and contribute to a low carbon economy, waste to energy sector, life cycle initiative, and so on. So please, Mr. Vano, the time is yours.
Yeah, okay. Sorry, can you hear me clearly, Bu Maya?
Yes, please.
Okay. Okay, so first of all, good morning, everyone. Good morning to our distinguished speakers and then professors, researchers, and our industry college. My name is Vano. I'm a founder and director at ILS. We are circularity solution providers and also biomass developers based in Yogyakarta, Indonesia. First of all, I would like to say thank you. Thanks to BRIN, especially Research Center for Biomass and Bioproducts and Providia that for inviting us, ILS, to be part of this focus group discussion. It is an honor for me to discuss and also can share the industry perspective in the session. Today, I would like to share an industry, our perspective on how coconut shell valorization or recovery can be used for beyond research. So the output and outcome can be used for industrial project combining biofuels and then carbon materials and then potential carbon value. So I think in this session we can discuss more about the project development that ILS conduct, and then from our perspective, basically the key question is about it's not only about coconut shell can be converted into the biofuel or carbon materials, but I think the more question is about how this research from BRIN and this collaboration, I think, can be translated into a scalable and then bankable and commercially operated low carbon asset from our perspective. And then next, sorry. So it is our portfolio. So basically we have several project development area. Basically we are coming from the palm oil focus because some of them basically is underutilized, but in last 2 years, we moved to coconut shell as our main focus. That we develop it into the material carbon like biochar and also the derivative product. So we established in 2018, and our business pipeline is basically the first one is project development for the biomass utilization, and the second one is suppliers of the biomass. It's not for the fuel only, but also for the materials, biomaterials like biochar and also the another bio-based material that can change the conventional material. So it is our processing facility. So I think the first one is coming from the Central Sulawesi. So we procure the coconut shell from the village-owned enterprise. So we also can empower them as a local farmer. We can secure the materials that come from the farmers. And then, so talking about the market opportunity, we know that Indonesia has a strong strategic position. Because we are one of the world's largest coconut producer, and then basically coconut shell is not only waste stream, but I think it is a potential that we can convert into the renewable carbon feedstock. And then talking about the opportunity, we have projection that actually it is expanding. So let's say the activated carbon from Mr. Ha discussed before, we can utilize it as an water treatment, and you know that activated carbon comes from the biochar that basically we utilize it from the waste. And then beyond that, basically we also have several application, not only into the activated carbon industry or water treatment industry. So we also can use the biochar itself for the green construction, and then coatings, metallurgy, agriculture, and even the carbon removal. And then we see that there is still a clear gap, I mean. So most coconut shell processing remains limited to the traditional charcoal, briquette, and small-scale activated carbon. So the opportunity is that we can develop the integrated circular carbon solution with higher value product and better environmental performance. And then, yeah, so that's why, as mentioned before, the market is growing. As we can see that it is the biochar market outlook. We can see that in 2032, we will achieve until $10 billion as a market value. And I think to achieve that point, we need something that, yeah, like this one, collaboration, and also cooperation within the researchers and also industry. And then, as I mentioned before, that charcoal itself can be used for any several industry application. Like the first one, as mentioned before, was water treatment. So it is as raw materials or feedstock that can be processed into the activated carbon. And the next that we can come from the cement industry. So we can use it as supplementary materials or additive materials within the conventional materials in cement and kiln processing. And then from iron, steel, and mineral processing, we also see the potential, the biochar itself as a reductant. So we also have several inquiries and also potential customer from global company that basically they need to shift the conventional coke or conventional fuel into the biochar, as they can use it in the high temperature processing in steel and iron industry. And then we can also see from another application, like in paint industry, we also have several inquiries that basically we just understood that the potential is very large, very huge, and also we can see whether that basically charcoal is something that not only see as a waste, unvalued waste, but we can see that the potential, the application, and the development is still very huge area. And the last one is biochar for soil amendment and carbon farming. It also can be used as soil fertility improvement. So all the application basically come from our market analysis, and also we think that from our capacity, we can't fulfill all the requirement. So that's why we need collaboration. And then talking about the developing a coconut shell carbon solution. So I think that all of us can more understand that basically we can utilize coconut shell with the processing like in the integrated pyrolysis, and then the output is not only biochar, but we can also obtain several byproducts that basically can be used also in this integrated system, like if we can see that biochar as the main product, but we can also use bio oil as a byproduct that can be used for the fuel intermediate, and also pyrolysis gas can be used as internal energy to improve the efficiency in the system. And then recover head, as we know that they also produce the heat waste, so we can absorb, and we can also use it as to reduce the external heat demand. And then basically, we still need also require the engineering integration. That's why research and also the output of this collaboration, I mean, we can see that the feedstock preparation, drying, and then condensation, activation, washing, drying, all the process basically need improvement. And from our perspective, it is the point and the gap that we can fulfill as maybe in this research, the output can be fill the gap on how to improve the product quality, and also the productivity itself. And then so we can see that it is not a challenge, but I think that we can customize and also engineer the process configuration. That's why it is based on the market and also client requirement. I mean, so let's say for to achieve the product quality and also to fulfill the market requirement, so we can adjust, we can engineers, we can customize the process itself, and then I think the different application will require different carbon characteristic. So let's say the fixed carbon, as content, moisture content, volatile matter, particle size, even absorption performance, all the specification will matters. So that's why I call it as an integrated system. So we can see that from the one product, we can adjust, and also we can customize the quality based on the market requirement, as we know it is still the gap. And then what industry needs from the research, I mean, the first one, the important one, I think, is about the product yield, because we know that the yield itself, the currently that we achieve is about 25%, so it is still low. And also basically it is based on the raw materials, but most of them in the coconut shell, I think it is still in 25 below. So we have to we can improve the yield itself. And the second one is quality, as I mentioned before, that basically it is based on the market requirement, and also we have to make adjustment like the operating and the operating, and also the specification of the process itself should be designed and customized. And then the efficiency, I mentioned, as I mentioned before, that basically we still need energy consumption reduction, and also to maximize the utilization of the pyrolysis gas and the waste heat. I think it is something that can be improved. And then the next one is product quality upgrading. So it is about the stability and also the properties of the product itself. And I think the next important one is about the operational risk. So I think the catalyst lifetime and chemical and water consumption, that's the point that I think we can challenge, and also we can solve the issue. And then another one, I think it's not only biochar as a product, so we can also see is at project carbon credit development. So it is another opportunities that we can also see as the value of the charcoal itself. So as we know that from the utilization and valorization of the coconut shell as a waste, we also can avoid emission, and also we can use it as a durable carbon removal. And also it is refer to the regulatory momentum, and also the initiative that currently in the global initiative, I think the carbon credit to be the something like happening. And then another one is about the value as a part of project revenue stack. So I think most of the biochar developers can see that we can develop not only the client requirement of the biochar itself, but also we can also join the biochar market, credit market. And then so it is our last slide. So let's collaborate, and also we are happy to collaborate with all the resources and also all the stakeholders that involved in this resource collaboration. So we are LS, we are not dreaming about sustainable future, we are working on it. Thank you.
Thank you. Please give applause for Mr. Vano. Thank you very much for the insightful presentation, explanation about your company, Mr. Vano. So, ladies and gentlemen, we will come to the discussion session. So, please raise your hand for anyone want to discuss or give a comment from the floor. Anyone want to ask or give comment? Okay, so maybe okay, thank you for that. Please, Pak Dawam.
Thank you. Especially I would like to asking or comment to the Mr. Chep. Thank you for your nice presentation. So I would like to know, do you have any plan for entering new business for your coconut, especially for energy? You said that you just make several products related with cocoa fiber, cocoa peat for planting or for roof, but I didn't see about your planning for next that we are talking today about energy. Do you have any plan for that? Thank you.
Hello, Pak Cepi. Okay, join again. Please. You can answer in Indonesia or English, both is okay.
Sorry Bu, baru gimana masih di jalan sih.
Yeah, thank you, Pak
Thank
Cepi.
you.
So, simple
Yeah.
question. Do you have any plan for
Yeah.
your company to entering a new business for coconut for energy or energy storage?
Ya,
Or making carbon
Pak Dawam,
for...
terima kasih. Jadi memang ya, jadi memang kita punya planning untuk pengembangan sabut kelapa khususnya untuk jadi energi. Kenapa? Karena site plan kita yang ada di Tobelo itu satu hari kita punya rencana produksi sekitar 350.000 butir kelapa, Pak. Jadi one day 315 billion nut. Nah, cocoa fibernya kita belum punya planning mau. Nah, si cocoa fibernya itu punya potensi untuk dijadikan sebagainya. Nah, itu yang perlu mendapatkan support dari BRIN terkait pengembangan produk itu, Pak. Karena kalau tiap hari nanti saya bakar kan sayang sekali gitu kan. Itu potensinya sangat luar biasa. Satu hari 350.000 butir kelapa.
350.000. Oke, Pak Dawam.
Thank you.
Okay, thank you.
I have one
Please
question for you.
proceed.
Yeah.
And the materials, carbon materials is the base, but for the energy, especially for the like the pyrolysis or the gasification. So walnut shell is so different. So maybe if you can, you hope to get more materials, right? More materials, more carbon materials from the coconut, but you have to reduce the energy of the gasification or the pyrolysis. The liquid yield or gas yield, because you have to make more carbon, solid carbon. So it's the balance. So do you have any technology to make the balance if you want to get more materials? Of course, the energy production will be good. So do you have any technology? Just use the pyrolysis or like the low temperature gasification or?
Okay, so can you catch the question, Pak Cepi, from Professor Zeng?
Dia nanya teknologi atau apa ya?
Iya, lebih menanya teknologi terkait dengan apa pirolisisnya ya, suhu rendah.
Jadi saat ini kita masih belum punya.
Cepi, nah,
Ya, kita belum punya, Bu. Belum punya teknologi.
not yet developed. Yeah, not yet developed for the gasification of. Or maybe we can ask also for Pak Vano, Mr. Vano, sorry. Maybe can you give some comment about the Mr. Professor Zeng question?
Yeah, thank you, Bu Maya, and thank you, Mr. Zeng, for the question. So today we have the pyrolysis reactors, but as I mentioned before, that the yield, the output is still low. So it's about below 20% as the yield. So basically, it is our challenge, and we are currently looking for the solution that we can develop to increase the yield, and also, I mean, not only the yield itself, but also the energy efficiency. Because currently we have more than one energy stream, so we also use gas and also the biomass residue. So we have dual system for the burning system or for the heating system itself. The first one is coming from the gas burner, and the second one is biomass burner. But I think our current situation is about the raw materials is that we get from the suppliers. I think it is still a wet base, so we have to dry it. So that's why we still need more energy to decrease the moisture content, something like that. So that's why, I mean, the energy efficiency is still low.
Very important,
Yeah.
right?
Yeah.
Okay. So thank you, Mr. Fano. Is this clear, or do you have any question? Okay, so Mr. Fano said that it depends on the type of the resource biomass. So we still have time. Okay, Dr. Irfan, please, and also Prof. Vidya.
Thank you for your presentation. I want to ask question to Brother Fano. Please tell us about the type of the gasified products you are collecting. For example, are you able to collect the gases as you say that the yield is very low, but what type of the gases you are collecting from your technology, from your side, the gasified products of during gasification or after gasification of the gases you collect, because we can the gases into energy for meeting our daily requirements. So please give us input about that. And from the Chinese side, from our guests, we want to ask Professor Neheng about Professor Zifeng. Professor Zifeng about is there any advanced technology from their side that they have developed to utilize and harness the gasified products from their side, from China side? Do we do technology for the gasified products? Please also comment from your side. Are you able to harness the products for alternative products as an energy source for running energy demand? Thank you.
Okay, so maybe first, Professor Zeng, do you want to give some comment about Dr. Irfan? And then after that, please, Mr. Fano, you also can give a comment about the Dr. Irfan question. Please, Professor Zeng.
Okay. From China side, I think the gasification and paralysis is different technology route. Different. For gasification, most of we get the gas. This gas for burning to energy to make heat. Right? So maybe you can produce a little bit carbon, but not so much. But this carbon, the quality is high. It is good. Analysis, most of we produce carbon. So sometimes we don't need the gas. This gas maybe just burning it and sometimes we return the heat to heat the carbon, to heat the raw materials. So it's different. Yeah. But in this process, sometimes we don't need any liquid product. That means we can get reduce the cost, the carbon and the gasification. Yeah. So of course, for the academic, when we research on gasification paralysis, we need to balance different, right? But in the industry, maybe we don't consider so much because it's a different products. So thank you. Yeah.
Okay, thank you, Professor Zeng. So we are welcome to comment from Mr. Fano regarding Dr. Irfan question, please.
Yeah, okay, thank you for the question, Dr. Irfan. It is interesting to be discussed because our system basically it is a conventional. So we just modified the outlet of the gas. Basically, we just what is it? We just burn it, the gas itself. So our system is basically isolated system. So there is no gas output, but the output is something like non-condensable gas because we have a condenser system on our system. It is integrated system. So from your question, basically the gas itself, the pyro gas, I mean, is directly used in our system with integrating or connecting the gas output to the burning system. So we just burn it in our system. There is no system like capturing the gas or absorption the gas there is no system in our process.
Thank you. The next question coming from Professor Widya.
Thank you, Pak JP dan Pak Vano for all industrial perspective today. It is will be enrich our. I would like to ask to the you said that you set up for the pyro. Maybe traditional one or maybe conventional ones, and how is the capacity? How much the capacity for the pyrolysis setup? The second one is when you convert for the biomass into the energy. I mean, what kind of in your business? What kind you have goals? Theoretically, I mean, the process condition will be influent on the properties of the products, of course, and your business, it is the main feedstock. You said that about the from palm oil biomass. So we know that in the coconut shell that we use in this project have promising for the carbon properties, right? Even I don't know exactly comparing from the literatures comparing with the other biomass, it can be more better for energy storage in this case. How is do you have maybe any suggestion for next? How is if in your you have our project also will be here we can set up in the lab, but the problem next, how is scale up still have similar properties with the lab. I think it is my question. Maybe you can give some comment for that. Thank you very much.
Okay, thank you, Professor Widya. Please, Pak Vano or Pak JP, both of you.
Yeah, thank you, Prof. Vidya. But I apologize for the unclear voice in my side. So I will answer some question that were from my side. So I think the first one's about the capacity. So yeah, basically it is a conventional one, and we have it's about 150 kilograms until 500 kilograms per batch, because it is batch system. And then actually our challenge, our next challenge is to develop the semi-continuous or even it is continuous process, because we know that we can't do the something like continuity system as our current system is that basically still what is it, control we have to control the air and also oxygen, because we know that it is oxygen free. So that is the point that actually we want to plan and to be developed to develop it as a continuous system, not as a batch system. It is the first one. And then the second one, I totally agree with Prof. Vidya in terms of the coconut. is a good one rather than another biomass, as we know that I has mentioned before that basically the charcoal can be used for any industrial sectors, and I think from our recent market research, basically coconut is the resource that I think it is a most most finding resource. Some of our clients and also the market requirement need to coconut as raw materials. So it is the point that basically we can consider it, but again, we have several challenges like Pak CP Manggubumi said previously. It is a supply chain, the first one. So we know that we have to obtain from the farmers, from the community, the coconut shell itself, and it is a challenging for us. And the second one
Sampai 40,
is
Pak.
pre-treatment process. I mean, because some of the market requirements need the low moisture product, so that's why we have to decrease the moisture content, and also to decrease it, basically we need one additional process. Basically, it is a cost consuming as well, so that's why we concern it. The feedstock price itself is increasing, but we have to control the quality, and also we have to control the price itself. So that's why it is the challenging for us to fulfill the market needs. Profit, yeah.
Okay, thank you, Pak Vano. Please, Pak Cepi, maybe you also can answer and komentar from Profesor Widya.
Baik, terima kasih Prof. Widya. Sebetulnya saat ini KOIR Indonesia belum menggunakan energi untuk proses pengeringan. Tapi kita yang tadi saya sampaikan di akhir tahun punya planning untuk memproduksi kokopit dan kokocip itu 1 bulannya sekitar 60 kontainer. Nah, dari referensi yang saya baca dan yang saya cari sekarang, proses pengeringannya kita memang perlu menggunakan open. Kalau pakai gas dan pakai listrik kelihatannya tidak visible untuk kita lakukan di lapangan. Jadi opsinya satu, saya akan menggunakan tadi sisa coco fiber yang ada, atau kalau tadi ada ide dan punya referensi terkait energi yang bisa kita gunakan, karena nanti proses pengeringannya itu dia harus continuous 24 jam. Itu merupakan salah satu harapan saya dari KOIR Indonesia untuk BRIN dan para periset yang lainnya, karena itu akan sangat membantu untuk proses pengeringan produk yang harus sesuai dengan standar market untuk ekspor. Terima kasih Ibu Maya.
Okay, thank you. A short question from True.
Okay, thank you so much, Bu Maya. My question to Pak Vino, regarding the operational of the pyrolysis equipment. The short question, Pak Vino, just want to know that the temperature for the process and also the reaction time on 150 kg, how long you take the process to get the final result. Thank you so much.
Okay, the last question.
My question is to Dr. Fano. One is the industry's major challenge is the scale up, correct? So I think I need scale up, which is the best technique. And another question that will be adjoining to it is, what is the major quality control techniques that you think is the best to understand the industry scale activated carbon? So, yeah.
Yeah, Thank you very much for the question. So again, I apologize for the unclear voice that I get, but I will answer the point that it is clear for me. So the first one is about the processing condition. So it is the temperature itself is about 400 degrees
400.
Celsius. It takes more than 1.5 until 2 hours. So it is, and also it is a batch system. So after that we have to quench. We have to make dry quenching. Yeah. We have to wait for until a half day to can cultivate or to can get the output product. So it is the current situation in most of, I think most of the operational process in carbon industry in Sulawesi. I mean, because we have several partners in Sulawesi and they have do the same like what we do. And then so it is it answering the question?
Yes.
Okay. Okay, so sorry, the second one, it is not clear for me. I don't know. It is the internet connection. I mean,
Oh.
so so basically, as I get the point from the second question is about the scalability, and I think totally agree with that. So the current challenge is basically how to increase the production capacity and also shift from the conventional one to the, I think, the more efficiency one, because when we refer the, I think, the European technology, they have several, I think, the pre-treatment and post-treatment that basically it is not used in the current application in Indonesia. So basically, that's why my point is about how can we make the system more in continuous system, and then basically again it is based on the raw materials and also the product specification. So most of them basically we have to the first one is to decrease the moisture content, because most of the application, industrial application, let's say from the metallurgy, mineral processing, and also even it is a briquette industry, they require a low moisture, low moisture product that they can obtain from the producer. And then the second one is basically, yes, again, the challenge is about I think it is not the main idea that we discussed today, but I think most of us in the field face the challenge in supply chain. So it is I mention it oftenly because we face several challenges in the supply chain itself. When we see that the palm oil can be a good reference for us, in the charcoal, in the coconut, we are very different, and it is far away from that condition. So the complexity of the cooperation within the farmers, even when we obtain the coconut shell itself from the farmers, because they cultivate them, and then they can supply it to us. Basically, some of the feedstock itself, we need something like, quality control in the upstream level. So I don't know, because it's about, again, it's about the, I think, the sizing, and also even when we talk about the activated carbon or the biochar product as a end product, we also have to concern about the homogeneous material itself. So some of the suppliers basically give something like they didn't use something like a standard procedures for the pre-treatment process, like crushing or make them in the same size, in the same or similarities, something like that. So it is, I think, the complexity one is about the supply chain and the ecosystem, the local ecosystem. I think that's the point from my perspective to scale up this the coconut project.
Okay, thank you, Mr. Fano, and also Mr. Chepi. Ladies and gentlemen, as we come to the end of the session, so I would like to express my appreciation. Thank you so much for all the speakers for very insightful, sharing technology, sharing information, and thank you for all the participants for the fruitful and active engagement discussion. By presenter and also all the participants, the idea, the recommendation, and so on can be a good foundation as the successful of this project. So thank you, everyone. That's all from me at moderator. So I would like to send back to the MC today. Thank you very much.
Okay, thank you very much, Prof. Maya, for moderating the session. We would also like to express our sincere appreciation to our industry speaker for sharing their valuable perspective. As a token of our gratitude, we would like to present electronic certificates from PT Coir Indonesia Global. And then Mr. Ha Changbin from PT Indukarbon Primajaya. And also Mr. Vano Alfian from PT Cipta Inovasi Berkelanjutan. In addition, we would like to present a certificate of appreciation to Prof. Maya for serving as the moderator of this session. May I kindly invite Dr. Gerald to come forward and present the certificate for Prof. Maya. Okay, thank you very much, Dr. Gerald and also Prof. Maya. Ladies and gentlemen, we shall now proceed the project presentation session, which will be moderated by Dr. Nages Kadri. Dr. Nages Kadri is a visiting researcher from the Research Center for Biomass and Bioproducts BRIN, Indonesia. He is also an assistant professor in the Department of Chemistry on Sesadipuran Institute of Technology, India. His expertise are nanotechnology, supercapacitor, battery, and electrochemical sensor. May I invite Dr. Nages Kadri to take over the station. Dr. Nages, the floor is yours.
Thank you, Doctor, for the introduction, and good morning to all distinguished professors, industry experts, and the researchers. It's my great pleasure to welcome you all for this panel discussion. Today we have been discussed about inspiring. Now we are about to listen to the panel discussion about ideas, identifying current challenges for future collaboration between academia and research. It's my honor to introduce our distinguished panelist. I now invite Dr. Van Dekau, lecturer, Energy College of Energy, Xiamen University, China, whose expertise include heavy oil upgrading, solid fuel conversion, and catalyst development, and also who will be accompanied with Dr. Amalia Amin, who is the researcher at Research Center for Catalysis BRIN Indonesia, whose expertise lies in material chemistry, catalyst, and catalysis. The floor is the floor is for you to discuss. I invite both of them for the presentation. Thank you.
Okay. Hey. Good morning, everyone. Okay. It's in here. Good morning, everyone. My name is Wang Detao from Xiamen University, and I will show my teams on the show my presentations. It's over there. Oh, it's there for there. Okay. It's okay. Right. Oh, yeah, it's my slide. Okay, thank you. And my debate topic is about on the catalyst preparations for the catalyst process of Western coconut cells. Please next. For the current research, as we know, if you use the pure pyrolysis technologies, because the BIOS because for the as for the conversions of the coconut cells, the conversions may be low at low pyrolysis temperatures, such as the conversion rates may be 30 or 50 conversion rates, so it's not too high. As for the selective of our desired product, the selectivity is also low, because as we know, bioresin has has large of oxygen. These compounds is very difficult, so this is why we need to be by using the catalytic pyrolysis for upgrading these bioreals. And the second, the last one we should be noted: if we use the catalytic pyrolysis for upgrading these bioreals, the use of catalyst is also we need but as we know that for the current report work, most of are focused on the zeolite materials. They have high selectivity, high carbon materials, but these zeolite materials also have some problems, such as deactivations by carbon depositions. So in this work, we use the carbon materials from the coconut cells. This is good carbon materials. So the main gap is the first one is the relative low conversion. The selectivity of hydrocarbon materials, such as the aromatic hydrocarbons. The third ones, we need to find proper solutions to improve the long stability or regeneration methods. Okay, next. So as we know, for the our work have some do some researches on these catalyst process. For as we know, when we prepare the catalyst from our lab, we usually use the traditional heating equipment. But we know that this also takes a very long time. In my labs, it also when we set to the desired temperature, it may be takes such as several hours to the desired temperature after heating for a long times and cooled down by nature. So it maybe takes one day for obtain our catalyst. But we propose a new. It's quite very different, because we can heat it these samples in very few seconds. In our labs, it may be very far heating rate. So if we set this temperature to about, for example, for 600 or 700, it may be about 10 10 minutes or 15 minutes. No, 15 seconds. So it's very fast. And after we set this to the desired temperatures, it can be faster cool down to room temperature. The centering of the active bentos, so we can keep a very small active bentos. So we can see these short videos. You can if we hit to the temperature, we can hold at this temperature for about in our lab we only take 30 seconds. After that, it will faster to the room temperatures. So we also make some comparisons. One. As we can see the figure 1 and the figure B, we use these methods by the traditional heating equivalent. But we also investigate the different atmospheres by hydrogen and by argon. So we can see that by using these methods, we can obtain the catalyst, but this catalyst has large bentos. So when we use this catalyst for the catalytic process of pan-wood, so that is the activity then may be a little low than the zero heatings. So as we can see the figure C, we can see that the bento particle size is very small and have a very uniform distributions. So when you use this for the catalytic process, one is that we can obtain the hydrogen-rich gases. On the other side, we also analyze the product, the bio-oil product distributions. We can see that these bio-oils contains lots of aromatic hydrocarbons, so it's our desired product. So it's a good result. But as we think that for the different biomass materials, the results may be different. So in our next works, we also need to be collaborated with Professor Widias by changing different materials such as would be different results. But from these results, we can see that the small for the catalyst, the small bento particles can be operated. And the other side, we can obtain the more high yield and high selectivity to the our desired products such as hydrogen-rich gas and aromatic hydrocarbons. That's our current research work. Okay, next. For our next research plans, we can see that for the increase the commotions of our coca cells. I suggest that we can add some bentos such as these two types of bentos, and because we can see that after added to the bento source, we also have some increased the commotions and can control the product distributions. On the other side, as for the biochar, it has a more higher specific surface area than the traditional pyrolysis process. Sorry. For our side, that as for the catalyst preparations, we also need to be increase the stability of our catalyst. So one of our strategies is to by preparing the nickel-based anode catalyst. These catalysts we in our lab will be showing better performance than in our next work. For the third one is the prolonged catalytic activity. As we know, during the pyrolysis of biomass, one of the bigger problem is the deactivation of the catalysis. So we propose a strategy. One is that we can use the steam assist by catalytic regeneration. This will be an idea. And the other side that we can use the gel heatings assisted regeneration. This part we have used it, and there can be some more good results. But the catalytic performance of the regenerated catalyst still show lower activity than the fresh one. So it's also a big challenge for us. And the third one is that we can also regenerate our catalyst by hydrogen-rich atmospheres. This could be because during the pyrolysis, some of the bento exercise will be changed to the bento oxide. So the catalytic of our catalyst will be some loss its original original activity. So one, if we could regenerate our catalyst, use the catalyst under the hydrogen participants, it's also a good idea to regenerate it. So the 32 and the 3 we also use the the 31 we don't use it, but I think it's a good idea for the recover the catalytic activity. And next, okay, that's I want to show our
Okay, first of all, good morning, everyone, all participants here. Let me introduce myself. I'm Amalia Kurnia Amian from Research Center for Catalysis, and today I will be presenting part in a MOST-RIIM project, which is about the hybrid catalyst preparation technology based on carbon-supported hybrid nanocatalyst, manganese molybdate supported on biochar. It will be led by Dr. Atika for the technical process improvement or development, and for me is nickel carbamide supported on nitrogen activated carbon. Okay, next slide, please. Here, before I mention about the current result, previously I've been experienced in development of hybrid nanocatalyst called vanadium pentoxide activated carbon and cobalt iron layer double hydroxide reducted graphene oxide as electrode. And here the synthesis strategies will be easily to bring me to develop our proposed catalyst. Next, please. Okay, here we propose to integrating a nanoparticle from metal manganese molybdate or nickel carbamide on supported carbon. We know that carbon-based material having a exceptional conductivity that can support for that was conductivity that bring channeling for transfer ion, right, Miss? Okay, and that will be facilitated to encoding also encoding nanoparticle here for from aggregation, so we can integrate a redox active site easily to have a lot of surface area here to improving a synergetic development of hybrid nanocatalyst. So the main strategy we develop this catalyst first stage is for optimizing the nitrogen dope on carbon support. In my hypothesis, we must take optimization in a calcination process or pyrolyze in a range of 700 till 800. So we can optimize which and dope nitrogen bonding on the carbon. It is a engraphitic and pyrulic, or the last one is sorry, this yes, yeah, pyridinic. To have a graphitic end of carbon, it can facilitate a more stable configuration of end of activated carbon, but in somehow pyrolytic, we can generate a better so we must optimize first. After that, if we have already having optimum condition, we next to comparison of sodium hydroxide, alkaline to have activated carbon, which the conventional is calcium oxide, and then we compare to the co-activation with calcium oxide and ZnCl2. After that, we must develop the integration of synergetically with the metal oxide base to achieving higher density and maximize performance in supercapacitor to again generating better ion transport, your faster charge discharge, and etc. This is enough for our stage. Next, please. Okay, that is the plan we will done. Okay, I think that is. Thank you.
Thank you, Doctor, for your insightful presentation. Now we have the speaker from Group 2 who will be giving a talk on catalytic pyrolysis technology. It will be given. The talk will be given by Dr. Epip Amrula, a senior lecturer, Department of Mechanical Engineering, Faculty of Engineering, Lambang Mangkurat University, South Kalimantan, Indonesia, whose expertise lies in pyrolysis, supercritical water gasification, hydrothermal treatment, biomass, and waste to energy. And the talk will be accompanied by Imran Masfuri, who is the chemical process engineer at the Research Center for Fuel Technology, BRIN, Indonesia, who's expertised in thermochemical process for bioenergy and waste to energy. So the floor is to you to discuss. I pass on to the mic.
Okay, thank you. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. First of all, I would like to thank to Professor Widya, lead of this project from Indonesian side, and also thanks to Prof. Zeng, lead from the China side. My name is Apip Amrullah. I'm from Department of Mechanical Engineering, Lambang Mangkurat University, South Kalimantan. Actually, today I would like to talk about the catalytic pyrolysis technology research development regarding the how to the catalytic pyrolysis technology process, and also the converting the some sources, biomass sources we have in Indonesia. Okay, next. On the thermochemical conversion for conversion of the biomass and other resources of the plastic waste, we try to develop the technology, and also we try to conduct the experimental using the pyrolysis, slow pyrolysis, also the integrated with the another catalyst that we can use to produce the bio oil, biochar, and also the hydrocarbon that produce will potential application for the sustainable efficient fuel and other low carbon energy system. Okay, next. Oh, I think this is the all dot all one here. Sorry. Yeah, actually I already changed the. This is the old one. I'm so sorry. The right. Sorry. Hah? Yang muda-muda. So sorry. Kalau Pak Adi mungkin all out ya. Apa? Ada solusi yang 20 yang di nomor 2 berarti nomor 2 ini ya yang 22 ya. Sorry for this biar nggak terlalu tegang Bu ya. Kita santai. Oh gitu. Saya suruh Pak notif. Oke. Slide so. Yeah. Okay. Good. Okay, the next slide, please. Okay, next. Okay, this is our current research. So as I mentioned before, that the from the pyrolysis, as we know that actually the pyrolysis there is three categories. The first one, which is the slow pyrolysis. So the product optimosis is the biochar, and then the second one is the medium. I mean that the process will be maybe 50-50 for the biochar and also the bio oil, and the fast pyrolysis should be the optimum product is the bio oil, but the consumer energy should be high of course. And then in this case that we conduct in the slow pyrolysis, and the slow pyrolysis, which is the temperature vary from the 400 degrees C to the 600 degrees C with the pressure room temperature, and also the reaction rate is around 40 minutes. And then this is our product in the current research. We focus on the pyrolysis of the macroalgae, rejected macroalgae, not compete with food. So there is the three type: the the green, red, and also the brown macroalgae. And then we are feedstock, and then this is the product from the brown macroalgae. Yeah, so we integrate with the catalyst in this experiment. We doing using the ZSM5 and also the Amberlist 15. And the interestingly that we obtain that most the chemical compound that obtained from the bioil is the aromatic hydrocarbon, almost 40 to 60%. This aromatic hydrocarbon. Therefore, from this result, we think that we need to moving on into the sustainable efficient fuel, because we know that if we talking about the SAF, the aromatic hydrocarbon is the most important things, right? So this one, 2026, this on our project also. Then another project, we conduct the production of the jet fuel ring aromatic hydrocarbon from macroalgae pyrolysis using the zeolite ZSM5 catalyst. And also, in the other hand, we try to optimizing the process, as the another speaker that they mentioned that the optimization process is more important. So in this study, we try to develop the model kinetic reaction model to compare with the process optimization by using the response surface methodology. Even we use the CCD or the BBD. Okay, the next, and then next slide, please. And then our research plan, because we already know that the best result if we use the ZSM5 or the another catalyst. So we try to think the another catalyst can be improved. The first, aromatic hydrocarbon content in the bio oil, and also the optimization process. So the rest, our research plan in this project, we try to vary the catalyst using the acidic zeolite. For example, the ZSM5 is already done, and also now we try to moving on the metal load catalyst, nickel combined with ZSM5 dan another. So we hope that the process for hydrogen transfer should be enhancement. So because the if we talking about the SAF, so it means that the hydrogen hydrogenization process will be occur in this process. Hopefully we can get the higher suffering for hydrocarbon and also the another products like the activity carbon and other gas comparable gas. And then the third one, using the carbon-based catalyst, of course, we try to use the another catalyst to focus on the catalyst rationality evaluation. Of course, there is regarding for the economic value. And then the another hand, we try, of course, to think the optimization process of the by using the response to replace methodology. And then we try to develop the kinetic reaction. Even we use the first reaction order or second order to improve to get the data and the comparison of the actual data and predicted data. So I think this is the more crucial when we try to vary the kind of the catalyst, maybe, or the difference of the temperature, reaction time, and also the percentage of the feedstock we can use. So this is my short or briefly research we have been done, and also we will do in the future. Thank you.
Good morning, distinguished professors, researchers, and all the college. My name is Imran Mashuri from Research Center for Fuel Technology. Thank you. I would like to present about the catalytic pyrolysis technology. This research activity is conducted with Dr. Novi. Yeah. Next, please. Yes, this is my previous research, the development of our research from the 26. In 2022, my research about the co-pyrolysis of non-biomass waste into synthetic liquid fuel. Then in 2023, we expanded, we was expanded to the production, purification, and quality enhancement of bio-oil through the integration of pyrolysis and catalytic upgrading processes. Then on 2024, we have some research about the production of bio-oil and synthesis gas through the co-pyrolysis using diversified aquatic biomass as feedstock. And also evaluation of hydrothermal carbonization potential for palm oil mill, a pathway to net zero emission. Then in this year, we have a collaboration with Professor Widya to development biomass, co-pyro for bio-oil and biochar. And also in this year, we developed biomass gasification technology for syngas production as an alternative energy sources. In addition, there are several innovations have been registered as patents. Some of them include multi-feedstock auger pyrolysis reactor, then process for producing biomass powder from seaweed residue, method for producing biomass pellet fuel, then method for enhancing biochar quality from corn cob waste. And the last one in this year, we have a registered patent about the shaftless ribbon screw pyrolysis reactor to scale up in industrial capacity. Fortunately, in this year, we have collaborated with the private company in Jambi about the palm kernel shell to pyrolyze that palm kernel shell into biochar So we have the last technology about the selfless ribbon screw pyrolysis will be upscaled to 100 kilogram per hour. Then we will upgrade more 1 tons per hour. Okay, next. This is our current research. The research about RIIM MOST. We have conducted the preparation. We have a sample of coconut. The sample preparation is the and also the experiments. Then the moisture and the particle size below 40 ms or around 400 microns will be introduced into the horizontal angle reactor fixed bed capacity laboratory scale. We use the conducted in the near oxygen atmosphere. In the finish of the experiment, we will obtain the oil, biochar, and the gas. Okay, next. Yeah, this is the preliminary result about the cocopiro. The figure left side is solid product biochar. From the yield table, we can see that the biochar yield is high. Then it will of pyrolysis. This product will increase with the increasing of the temperature of pyrolysis. On the left side of table, test of the biochar product. One of the biochar product at 400 degrees Celsius. This high fixed carbon is very potential for carbon-based material or other purposes. So increasing the temperature of pyrolysis, we can see that the calorific value of biochar is increased as well. We can see that at the very high calorific value of biochar, the up to 7 with middle high coal, such as bituminous. And then the figure on we analyze further for the characterization. Okay, next. Yes, this is the functional group of the bio oil. There are 3 that we can see that we know that the groups. Okay, next. Research plan. for next month, maybe we will conduct some group of catalysts for upgrading bio oil. We would like to employ the 3 groups of catalysts by Dr. Haris. Then the second one is alkali earth catalyst. Transition catalyst. 1 and 2 will be associated with pyrolysis process, but of the third catalyst will be associated with hydroprocessing and hydrodeoxy. Catalyst, I expected that it can contain and so on. Okay, next. Okay, that's all from me. Thank you.
Sorry for your insightful talk. I now request for another group to be delivered by Dr. Research Center for Biomass and Bioproducts, BRIN, Indonesia, whose expertise lies in biomass-derived carbon for energy storage, pollution removal, water and air purification, pyrolysis, and hydrothermal carbonization, and who will be accompanied by Dr. Nidya Chitranganu and Bioproducts, BRIN, Indonesia, who is also the BRIN manager of the Research Collaboration Center for Biomass-Based Carbon Material, Carbon and Biomass Energy, who's expertised in the biocarbon materials. I invite both of them for the for delivering the talk.
Stand beside you. I will stand. Bismillahirrahmanirrahim. In next 5 minutes, we will discuss about how to produce carbon or activated carbon and how to modify the product. Where is the slide? Where is the slide? It's 10 years ago. Don't complain me. So we will divide my presentation. And then the second one is current work. And then biomass is a main candidate for activated carbon production. But still, when we produce activated carbon from biomass, it's inconsistent in terms of characteristic, particularly for supercapacitor material. So then our main focus, number 1, is how to size. Previous research, Kaliandra is fast-growing species in forestry plant, and then commercial lignocellulose, and then I use the steam, the conventional steam, and then the chemical compound. So next slide, please. Yeah. Study, I try to homogenize the porous texture. So in terms when I use the steam activator, the size of the pore is around 2 point something until 4 point something nanometer. So I try to decrease the size using, but the fact instead of just broaden the diameter to up to 5 nanometer. So this is my challenge, I think. So in the next plan, for BRIN MOST project, I will try the water cooling, the first one. So after final temperature, the water, the sample inside the reactor. The second one is like, and to increase conductivity and to add the sulfur to increase the wettability. So with this parameter, we will validate the impact of parameter activation to the pore size distribution, wettability, and conductivity, particularly, especially to
Thank you, sir.
Okay, thank you for opportunity. Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. Today I would like to present our second test of the test 3. We will modify our porous carbon with urea with the purpose of to dope the porous carbon with nitrogen using urea as the nitrogen source to enhance the performance and also for supercapacitor. Please next. And this is our proposed research letter. From this year to next year, we will focus on the material development and optimization of our porous carbon. And also at the second year, we will electrochemical properties and also the energy storage performance. And for the third year, we will focus on the application. With this. Please next. Okay, why we choose urea to dope the porous carbon? Because the urea is contain a high nitrogen content about 40 above 40. Also environmentally friendly, and then it is highly soluble in water, and also during the pyrolysis the species that is treated pyrodinic. And from this figure, we can see that the nitrogen during the pyrolysis will enter and the nitrogen atom will enter and also bond with the carbon at the porous carbon. And the benefit of the urea doping, it has the higher and can it is low cost, yeah. And there is one previous publication published by Chen et al. Doping using urea. The capacitance and the specific capacitance of the supercapacitor will be enhanced from 200 to 326, and also the capacitance retention also better, yeah, after doping with urea. And next, please. Yeah. We dope the activated carbon from OPFB using but not use urea. We use melamine as the nitrogen source, and then the activated carbon for the anode of the lithium-ion battery. And here we can see that from the XRD, from the FTR group. Yeah, and then for the PET surface area, after we dope the nitrogen, the surface area decrease, but the nitrogen content increase, yeah, from 4.2 weight% to 16 weight% after we dope with the ratio 1 to 2. And for the electrochemical performance of the lithium-ion battery, after we dope with the melamine with the nitrogen source, the discharge capacitance is increased from 219 to 314. And also the Coulombic efficiency also increased from 50% to 70%. So that is our purpose research.
Insightful presentation. Now moving on, we have the a group discussion on biomass-based energy storage devices, which will be delivered by Dr. Xiamen Zheng, University, China, and is the president of Fuji Association, deputy director of Supercapacity China, electronic standardization, Carbon Professional Committee of China, whose expertise lies in energy storage technology. So we are privileged to hear from you, sir.
Okay, thank you. Task 4 is for devices. So for battery, so it's hard to do that because but we have some experience. We have a lot of experience to do that, so it's fine. So next, please. List the total, just the global aspect to insight into our task or our program. Yes, please. Especially in China, we are focused on the energy, like renewable energy and storage. Okay, next. Now we have two almost 10 years, two actions. One is that we call the energy term. We call it. So this is energy storage. Another one is the energy, the vehicle, EV vehicle, electricity EV vehicle. Okay, next please. So this our with 5. In this, the explosive grow a lot. Still explodes. Okay, next. So we call it energy storage is the basic industry in China. Like vehicle and new power systems and low altitude ocean economy, like and the machine robot. All this we need, especially now we have the data center. Do you know data center? We set up a lot of the data center. Next. Next, please. Especially in the capacitor, because we use the capacitor, supercapacitor, with supercapacitor. So especially the global capacitors market is about the 30 billion US dollars, 30 billion US dollars. So it's grown a lot, especially in China market. In China market is almost to 150 billion renminbi yuan. In 2031, it will be 200 billion. So it grow a lot, especially in the supercapacitor. Capacitor is not so much, but it's increased. If we can use in the energy storage, it will be increased. Okay, next. So especially in China 14th five plan is the supercapacitor carbon is as a key materials there. It's key material, especially in 2025, the action plan for the high quality development of the new energy storage manufacturing industry. We have the high quality action plan. This approach plan most are focused on the materials, energy storage materials, battery storage materials, especially like the high quality, high energy density, especially in the AI action plan for the we call it dual empowerment of artificial AI intelligence and energy. Will give especially the energy storage policies, especially the supercapacitor will be part of the AI. They use the supercapacitor in the next. Because we call it the capacitor. Carbon is different. All type of the activity carbon, but it's different. It's different. In China, we have like now you have some cooperation with this company. It can produce like distribution almost more than 2,000. Okay, next. Yeah, currently, most of captive carbon. And now we have like yes, 北海新石盈利So for in China, most of we are focused on the high performance activated carbon. This carbon can be used the 20 per ton. But most of the active carbon is just only 10,000. 10,000. So it's the 20 times of the active carbon. Of course, high clearly. So it's in China. Okay, next. So for task 4, we are focused on as we need to like the interface design. This interface design is different the active carbon and the process optimization. Up, not that one. Okay. Also, we need to the device assembly and testing. To do that, because we need to do a lot of things here. Materials is okay. So to the program, maybe active carbon, but this right. Another one, we need to like drying or the devices, and we need test the devices. So, but we hope we can develop a new method. This method we call it dry coating. Dry coating. Tesla, she has the dry coating technology, and this one will be wonderful one. So our research idea are technical roots, especially performance porous carbon materials, analysis the structure activity, activity relationship. Okay. Of course, we need to make the standard because for the devices, for the battery, if the material cannot be stable, maybe for several, 20 or to. So for the materials, we need to focus on the activation mechanism, port structure. Surface chemical. For the supercapacitor carbon, we don't need any like OH like this. And for the devices and this electrode engineering, this. So for the materials preparation and characterization, like the key process, especially the pretreatment, activated, and we need to dope nitrogen. Nitrogen. A battery, we need dope some nitrogen. Yeah. This nitrogen may be like urine. It's bad. It's okay. And here, like the Java heating. Do you know Java heating? It's heat very fast, very fast. So paper, not just for industry. And after that, the material, we need to have the characterization, and maybe we have to use AI to know the performance prediction. So this just for public paper. And also we need advanced technology devices, a platform to identify the materials, especially at the atomic scale, multi. And now we know or mining the structure and performance relationship. Okay, next. The second one is research on the efficient preparation high specific area, high surface area, and the narrow port distribution. That from nanometer to 4 nanometers, maybe the port be occupied 60%, 60%, more than 60%, or 70% would be better. Okay. This one, we need to activation process. Doping, natural doping. Okay, next. Especially flat sheet treatment. The material surface is more than 2,000. One, we need the AI-assisted material design and performance. Like we need to, of course, now we are set up the multi-dimensional database of carbon. We spend a lot on it. And of course, we can make an intelligent model of carbon and decrease the cost. Next, please. And the fourth, in a of course, this carbon can be used in the lithium-ion batteries or sodium-ion batteries. Okay, next. We need to get the conductor or electrode, the interface to make the interface. Of course, we have to like the slurry formulation system. Slurry, coating, and drying. That's the total process of the electrode. We have some devices in our lab and the lab. We need to all these component assembly and performance testing. This as in the pilot scale, a batteries production line. Then we need to get the supercapacitor. Now after that we GCD, EIS, a long-term life establish and make a measure the total performance. Next. And that's all. Okay, next. So we have established some production like the active carbon, of course the electrode materials, all that. Industry partner. Next. Such as we distribution carbon capacity meters, not meters. Okay, and we have different call it the dual organic salt activity. And next, please. Another one we have the KOH activated carbon, and we modified by the PF regime together. So this would be better. Next. And especially like we have the 850 is high okay. Is the normal one is about 200 F is okay, but more than is too difficult. So carbon and micropolars. Next. Next, please. And this is the mesopolars. Is 60%. Next. So we hope because policy and the market in China, in Indonesia, we can get any energy storage. We can activate carbon, and coconut. If possible, if we can get industrial or we can set up a company here or in China together, maybe we can move in high value added these materials and this company. Okay, thank you. Thank you very much. Yeah.
Thank you. Thank you, Professor Zen, for your insightful and informative presentation. And Satyavan, who is representing Manu, head of Research Center for Fuel, and followed by Dr. Mohammad Mattaki, who is the head of the Research Center for Catalysis, and Dr. Gerald Endang Timuda, who is the head of Research Center for Material Energy. Center for Biomass and Bioproducts. So,
Rahmatullah. Afternoon, still morning, yeah. Everybody here, distinguished guests from China, distinguished host, Professor Dr. Ahab, Research Center for Biomass and Byproduct, and other besides me, and also the colleges. So, this technology that you already present, technology that maybe combine the pyrolysis. So, and also promising products such as biofuel and activated carbons. But however, this technology also limitations of the technologies or processes. Maybe such as these technologies so intensive energy for this process. Well, environmental impacts. Then we use also the resource such as a coconut shell, and may have a limitation. So we need, therefore, more research about and only coconut shell. There other so huge and we need about further research about the technologies itself, some like the techno-economic of this process, pyrolysis or catalytic pyrolysis, and the alternative process that more or less the energy consumed of this technology. Commentary for this technology or proposed technology and Assalamualaikum warahmatullahi wabarakatuh.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. First, I would like thank you to Prof. Akbar Hanif Dawam, Prof. Vidya, Dr. Wang Dikau, and Prof. Dr. Zheng Zifeng for inviting the researcher from Research Center for Catalysis to collaborate on this project. First, I would like comment to the Dr. Wang Dikau. What about the conversion of your product after the adding of the metal salts into the supports? And then could you explain hybrid nanocatalysis? Nickel, cobalt, and something like that is metal transition, not nanocatalysis. Okay. Because in your project title, carbon supported hybrid nanocatalysis, but in the right, not hybrid nanocatalysis, but carbon supported metal transition or something like that. Okay, thank you. Just to comment.
Okay, thank you very much. Good afternoon. Wang Dechao, Prof. Dawam. First of all, thank you for inviting me and also the researcher in Research Center for Collaboration. In our center, we have facilities to from several types of biomass, including the coconut ash or coconut fiber. Result from this process, from this collaboration to be applied. Maybe one commentary that I want to ask is about usually the problem from biomass products. It's reproducibility. So maybe from different batch of biomass product, the result can be different. So how to collaboration, maybe not only we took we can so maybe classified what type of source materials that you use, standardization maybe before it is processed in the have a standard classification, which part, I don't know, maybe it's the water content or something else. We need to identify that first. Okay, I think that's all from me. Thank you.
Okay, thank you. So I would like to give my comment at morning until now. All of you already give a comment to us, and also at related with this material carbon today. At first, in the morning, we little bit more producer of carbon from coconut. You know, as we said yesterday, that we are biomass resources. Yeah, of course, for this point, of supply eager to another source beside coconut shell, because we have a lot of palm oil. Maybe there is a biomass. We call it a kernel. Maybe for our future learning vidya, yeah, because we have a lot of coconut from palm oil. Yeah, not good maybe, but for kernel, coconuts. Yeah, and the second one, yeah, we learn about catalytic organization. Catalytic catalysis. Yeah, we are very happy Pak Taki and team join to improve, to sharpening our research about catalytic. And the third one is about technological pyrolysis. As we know, this many topic that we talk about pyrolysis, but my question is, do we already have a facility of advanced pyrolysis? As yesterday, I talked to Professor Zifeng that you work with reactor with 2000 degrees Celsius more, yeah? But I don't know, do we have or not? So that's to become our discussion to our boss, yeah, to promote, to propose. We also have. So maybe next month or another couple of months next, we will go to China. Several of Bu Widya teams will learn how facility, especially pyrolysis technology, that we can yeah, improve our facility here, so we can catch what China already make for the battery or energy storage. And fourth one, I think this is the most important. This is assembling to the carbon, activated carbon. This only halfway, because it is not yet to get. So that is important. That's your presentation at the last. That is the last, not but least, because our capacity to make to assemble already talk. That is the most important. I know Pak Sudaryanto. Oh, the battery, Pak Sudaryanto. Facility. Make better your facility. But not least, we come to our conclusion for myself is, how about our Indonesian way? So we focusing to make a activated carbon or a carbon capacitor just to mastering this step, and we become the bigger player, maybe the bigger player or the biggest player, or we just to go until our finishing target to make a storage battery from carbon capacitors. This my consideration. Which will we choose for the first, maybe in the next 5 years or 10 years? Yeah, we are carbon bigger player, or battery producer. Which one we will choose for the first? Next. That's all from me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you all.
Yeah, okay.
Yeah, thank you all for your valuable comments. And now we have the session is now open for the questions, and we have some questions from the chat box. First is to Dr. Wang from Mr. Subhan. the question is to Dr. Wang.
Yeah.
Your flash Joule method really was interesting, and because it can cut down the time processing for the carbon at high temperature. Not only heating, but also it includes short time for how you can increase the capacity of the process, for example, for 1 kg precursor. And that's the first question. We'll go one by one. Process, for example, having higher
in our lab, the lab I show our colleges 10 grams of samples, but in China there are lots of companies sells the general heating equipment. Some of the companies can have the capacity to processing 1 kilogram precursors of by this general heating equipment. So it's okay for China companies by doing this. Yeah. The second question is that when we put our precursors into the gel heating furnace, the particles should be fine. So after we get out the final product, it should be the ultra fine particles. So it will not affect by the heating methods. But if we put the small particles into the gel heating furnace, the final results that we will obtain the large particle. Okay, thank you.
So, thank you, sir. I think it was convincing. Mr. Achmat Suban for Mr. Imran. Sir, the question is, what's the highest that can temperature? In terms of temperature, what is the highest temperature that you can reach by pyrolysis process? That's the question for you.
We have several facilities for pyrolysis process. We have the fixed bed reactor, auger reactor, and a bigger fixed bed reactor that we will visit to our laboratory in this afternoon. Yeah. For around and another one only 700 degrees Celsius, and another one.
So here, no, the same, there is a continuation. The carbon precursor from the biomass can be applied for the supercapacitor as well as the application. So how to increase the porosity of your particle from pyrolysis method? That's the question.
Okay, yeah. After pyrolysis as biochar, we can in situ process we can slower the heating rate of the pyrolysis, and also we can longer the residence time of the pyrolysis in the reactor. And another process, ex situ, we can use the activated dioxide temperature more than 800, 900 degrees Celsius.
Dr. Wang and Imran sir for your valuable insights and answers. And also we have another question from Mr. Subhan for Professor Zeng. So the question is, almost activated carbon for supercapacitor application came from coconut shell. That can like sodium ion. So we need hard carbon material much lower than the coconut shell. So the question is, now we have the coal, which is than the coconut shell and has a greater capacity.
Carbon materials, one is from coal, right? Another one, polymer. What kind of polymer? Like the phenolic, phenolic PF. Do you know phenolic? PF. PF, phenolic. From it's like the rubber. It's okay. Can you? PF. In China, I'm the vice president of the biomass. More information about this post earlier. But for coal, as we know, it's cheap. Battery utilization for battery apply ash. The ash is high. But okay, sometimes we have the we shall wash the ash to make the carbon clear. But you know, as we know, the carbon when you porous carbon from But now we reduce the cost, maybe less than 200,000. But for the biomass, maybe just 10,000. So not. So it depends. It depends. So batteries. But you can. Hard cabinet means it cannot be gratified. 0.355 nanometers. The lithium ion can insert it, but lithium is okay. Lithium energy. Okay, thank you. Yeah.
Thank you. Now the floor is open for questions. Any questions from the floor?
Sorry, previously there is some question and comment from research head of catalysis, maybe or need to give some reply from Dr. Amalia and also from other speaker.
Okay.
Okay, thank you for reminding the question, Prof. Widi. Hybrid nano catalyst, right? That the question is right. Integrating metal oxide, which is cobalt what or yang satunya tadi aku apa? Cobalt ya. Nickel carbamide with which is all of them is metal oxide, and we can incorporated in a carbon base which is dope activated carbon. So they're having metal oxide and inorganic materials and carbon base as an organic material. So that term can be called as a hybrid nano catalyst or hybrid nano composite. By anchoring the metal oxide on carbon support, we can having a metal oxide nanoparticle system, cause the nitrogen with having a lot of electron non-bonding can facilitate as an anchoring active site for metal. So we can having a metal nanoparticle in it. Yes, biochar is mesopore, so pore system. Yes, actually, biochar itself is a lot of porous material. KOH, aduh kok jadi debat. With a calcium oxide, we can with improve of that biochar, coconut shell biochar. As Prof for having two till yeah, so we must using KOH.
If you modify the carbon into nanocarbon, it's okay, but supported hybrid nanocatalysis, it's not makes semangan molybdenate and something like that is metal impregnation. Yeah. Not should, must.
Oh, yes, must.
Because the determination is
Okay,
different.
my apologize.
Thank you.
Thank you.
Because for the of the biomass, the tar, do you know the tar? It's terrible, right? It's hard to deal with tar. Tar is stick. Yeah, it's stick, and this tar can make. Yeah. Yeah. Bring down the catalytic activity. Why almost? Do you know almost from the public paper or in the industry? Carry the conversion of the tar into like the phenol or like the benzene, like this one, and benzene, toluene. Because after sometimes we use it like this. Let's record it as the pyrolysis. Produce the pyrolysis vapor, right? The vapor can be maybe in 300 or 400 temperature, and it's the vapor, it's a gas. Then the gas can be upgrade into BTS. Yeah. That means we hate, I think we hate tar. It's hate tar. But tar within how to make vinegar. This water vinegar with water, because when you pyrolysis after biomass, we can get tar and vinegar. This vinegar can put in the water, right? And carbon. Vinegar is okay. It can be easy to develop, but tar, so it's difficult. So why we use almost into the carbon, because tar can be into the carbon, so it's okay. But if we focus on the thinking about the tar, how to deal with the tar, especially in the industry. But for public paper, it's okay. You use a lot of nano materials, especially like PT, platinum, carbon, also the metals we can use in this one. But we have another, because GSMF, we just produce the BT, right? But we hope, especially in the oil, petrol, like petrol oil, there's the long chain oil, right? Not the PET. PET, when they burnt in is pollution resource. But for the line, the small line, maybe just eight carbon, almost 8 carbon. Its burn is very well, and then it will produce the CO2. So we have another technology to get the long chain alcohol, alkane from the biomass. This is another one. So just starting our program, maybe when we'll have a deep cooperation, maybe we have another lot of idea to work together. Yeah. Okay. Thank you. Yeah.
Yeah. Thank you. Thank you everyone for today's participation, and I would like to express my sincere appreciation to all the distinguished speaker and panelists for sharing their valuable insights and experiences. We hope today's exchange of ideas will not only inspire us for new research collaborations, but also will develop and accelerate the sustainable biomass technology and a cleaner tomorrow. And once again, we thank you for all the speakers, participants, and the organizers. And please join me in giving a warm appreciation for all the panelists by a round of applause. And now I hand over the session and ceremony to the MC. Thank you for the opportunity. Thank you. Thank you all.
Okay. Thank you very much, Dr. Nages, for moderating this session. Our sincere appreciation also goes to all presenters and commentators for their excellent presentations and valuable comments. Before we move to the wrap session, we would like to present tokens of appreciation to our invited speakers and commentators. May I kindly invite Prof. Dawam to come forward and present the token of appreciation to first Dr. Wang Dechao. Okay, please give applause for Bang Decha, Dr. Bang Decha. And then next for Dr. Amalia. May I kindly invite Dr. Muhammad Al-Mutaki to present the token of appreciation. Okay, please give applause. And then next, may I kindly invite Prof. Vidya to give the token of appreciation to Dr. Apip Amrullah. Okay, please give their applause. And may I kindly invite Dr. Adi to present the token of appreciation to Mr. Imron. Kasih untuk Pak Imron. Oke. Okay, may I kindly invite Dr. Hasnan to come forward and present the token of appreciation to Dr. Nages Kadri as moderator. Udah selesai. Udah selesai, Pak. Udah selesai semua. Pak Imran belum dikasih. Pak Imran udah tadi, Pak. Udah. Oke. Oke, thank you very much. Kan nggak dikasih. Kan kemarin udah. Katanya nggak dikasih. Tadi dulu. Pak Adi, and then Okay, next. May I kindly invite Prof. Vidya to come forward and present the token appreciation to Pak Adi. Okay. Okay, thank you very much. And ladies and gentlemen, we have now reached the final session of this morning program. First, may I invite the Indonesian Project Coordinator, Professor Widya Fatriasari, to deliver the wrap-up remarks. Prof. Widya, the floor is yours.
Okay, thank you very much for all of you that following all of states of the from the industry perspective, and also task discussion content. We learn more. We learn much of how is our project will designs. We try to design well, and then from the research head of the fuel technology, from the research head of catalysis, and also research head of energy material, material energy, and also from research head of biomass and bioproduct, we have many comment and also suggestion. One thing that I remember from research center, head of research center for catalysis, there is a must to must to revise, and the terminology is maybe something so we need to even even we try to design well, but terminology is important. Yes, it is what I learned today. Thank you very much. And also from all of we also learn about flash Joule, pyrolysis, that I think this technology is belonging by Dr. Wang Cruz. I think one of paper right now is still under submission. Maybe will be go through for the review. Then we hope that from this technology we substantial improvement will or also we deliver high novelty, I mean, from this research. And then I believe that from Xiamen University also have and will be improved more what is Indonesian side, but I think what we try to design in Indonesian side also some high novelty we try also, such like in the catalyst, and then how is we design for the pyrolytic catalysis, and based on the what is we result from the pyrolysis, we got for biochar, and then we got bio oil, and then syngas. We try to capture for the syngas. Our homework then, how from the research can be done well after the science, of course, and then from the Xiamen, we need for how is improvement from Prof. Zhang. And then many things that I learned today, not only from the presenter. And I would like to thanks for my members for 2 days, very busy and hectic for once, almost 1 week we prepare for this event. I hope from the Xiamen can be accept all of our guys if any inconvenience, all things. And then can for my closing, can you showing about the video for our teams, because the head of research center for fuel technology, head of research center for materials, energy, and also research center for catalysis does know how is our profile. Thank you very much. Let's see our profile. Thank you.
Thank you very much, Prof. Vidya.
Yeah. Maybe some internet issue. Yeah, I would like to resume for this video that from the BRIN, not only research center for biomass and bioproduct involving in this project, but we try to involve also the expert from other research center in BRIN. Any problem? This video.
Wait. Show us your video.
Okay. Okay, we are sorry for the technical issues. Before we proceed to the video session, may I kindly invite China Project Coordinator, Prof. Zheng Zifeng, to deliver the wrap-up remarks. Prof. Zheng, the floor is yours.
Okay, thank you. Almost 2 days, we take presentation. I want to say thank you for all of us, especially because we have this program, joint program, so keep us more close to do the research, to promote our activities between Indonesia and China, especially BRIN and Xiamen University. I want to say thanks for the video and your group here. Especially want to say thank you for the Taiwan. Taiwan. Yeah. He, he keep with us for 2 days. And thank you. And thank you all you guys came here and with the Zoom meeting on the internet, right? Thank you. And we hope we can make great progress of our program, especially to publish paper, high impact public paper. And we hope, especially Taiwan Third, we hope this program can be commercial but in here, right? So especially we can get some devices, some machines from China, China side, especially like the research facilities. It's cheaper in China. And also we hope you can visit Xiamen University soon. I think yeah, October you will visit us. And that will be the common activities between us. Each year we will have meeting, right? This year here, another will be held in China, and you are welcome to visit Xiamen University. And thank you very much.
Okay, thank you very much, Prof. Zeng, for your insightful remarks and for highlighting the importance of this collaboration. Okay, distinguished guests, on behalf of the organizing committee, I would like to extend our sincere appreciation to all speakers. On behalf of the organizing committee, I would like to extend our sincere appreciation to all speakers, moderator, industry representative, collaborators, researchers, and participants for your valuable contribution and active participation. We hope that today's discussion have generated new ideas, strengthened our partnership, and laid a strong foundation for the successful implementation of the Kokopiro project. Before we conclude this morning program, may I invite all speakers, moderators, project coordinators, and participants to join us for a group photo. Yeah, and the committee will kindly assist everyone in arranging the photo session. Yeah. And for the information, after the photo session, we will follow lunch break and the program will continue with a laboratory visit to battery laboratory and fuel laboratory.
Satu, one, two. 1, 2, 3. 1, 2, 1, 2, yeah. Okay.
Okay, you enjoy the rest of today's program. Thank you and have a pleasant lunch.
Tulisnya lah, Mas ya. Oh, 6M ya.